This railway is considered one of the most efficient and up-to-date of its kind in the world. It moves more than 1 million people a day over a 26-kilometre track above and below one of the world's most congested cities. For the people of Hong Kong, the mass transit railway has become an unparalleled asset. Journeys that used to take hours now only take minutes, and at affordable prices. Commencing construction in 1975, the initial system stretched some 15.5 kilometres linking Hong Kong Island with the Kowloon Peninsula. But because of the territory's rapid expansion, this was lengthened to include an extension of some 10 kilometres. Then, in mid-1981, work commenced on the new Island Line. One of the key elements in the railway's inception was that it should be financially viable, and to implement this, commercial complexes were established at key points along the line, one of these being the Kowloon Bay development, Telford Gardens. Numerous high-rise apartment buildings were erected, these being offered for sale with attractive incentives. This complex also houses some 100 shops, restaurants and recreational facilities, and has blossomed into a mini-city. This commercialization has been one of the railway's cornerstones for success, and the MTR has in a few short years become a veritable industry, what with its huge land development programs and smaller spin-offs such as station billboard advertising. While the mass transit was opening, the British company of Marple's Ridgeway was establishing its presence in the territory. Their first contract was a bridge linking Kai Tak Airport and a hotel complex. The company then went on to complete foundation and advanced tunnelling work on the Admiralty Station complex, this being for a future high-rise development. And on the new Island Line, Marple's excavated over 1 million tons of rock from a hillside, the fill being used for a land reclamation project. Perhaps one of the most important associations Marple's has had with Hong Kong's new Island Line is Causway Bay Station, or Contract 430. Tenders for this being invited in early 1982. Marple's joined forces with LTA, the international construction consortium with extensive mining experience, and was successful in tendering for this contract. Not only was Contract 430 a complex civil engineering undertaking, but it had a very pressing completion date and liquidated damage clauses. Both diaphragm and caisson walls were necessary around the periphery of the site, and within, 42 large diameter caissons containing the columns upon which the development would be erected. A road also runs through the site. 7 down consists of 7 levels of subterranean structure, and eventually 2 high-rise developments will be built above it, and when complete the entire project will have cost nearly $1 billion Hong Kong dollars. The center points of the structure are large escalators to move passengers between the station tunnels below and the street level above. Also contained on the various levels are E&M and other MTR-related facilities servicing the station and running tunnels. Connection between the station tunnels and the complex is through a series of passenger adits built as part of the tunnel contract. When both Contract 430 and the tunnels are complete, they'll become an integral unit with easy access to a shopping complex and the street level above. The diaphragm and caisson walls were constructed first, work on these commencing in July 1982. Because of the high water table and soil conditions in the upper levels, mainly reclaimed fill, beach deposits and decomposed granite, ground treatment was necessary prior to caisson digging work. Some 1,200 grouting holes had to be drilled, and 7 million litres of chemical and bentonite cement grout pumped into the soil. Only after this was done could the caisson work begin. The hand-dug caisson, although seldom used in other parts of the world, has become a standard construction method in Hong Kong's building industry. Essentially, a hole is dug in stages up to 1 metre deep at a time. Then supporting ring walls with reinforcement are concreted as the excavation descends. Once rock level is reached, the concrete rings are no longer necessary and conventional blasting completes the excavation. At the bottom of the caisson, a base is cast upon which a cage is built with vertical as well as horizontal reinforcement. The horizontal bars later being coupled to future slab reinforcement at the various floor levels. A concrete column is then cast surrounding the reinforcement. Up to 22 tons of steel are necessary for every column, each rod of the vertical reinforcement being carefully jointed with proprietary reinforcement couplers, each being tightened to a predetermined torque value. At each floor level, horizontal bars, also with couplers, are then accurately wired in place, ready to be connected to future floor slab reinforcement. Shift work was continuous throughout the caisson and column construction program, the work schedule following a carefully planned routine. Often, shuttering was completed at night in preparation for a concrete pour the following day. Hong Kong's long, hot and humid summers required the ready-mix concrete to be chilled in order to reduce heat generation in these massive sections. Heat was also a factor that should have affected the labor force, but they seemed to shrug this off, and other hardships as well. The constant dripping of water and the stifling humidity sometimes made working conditions near impossible, but the will and determination of the workers constantly surprised everybody. A major problem facing the construction team was the road that ran through the site. All existing public utility services located underneath it had to be maintained. Extensive steelwork supports were necessary in order to preserve electricity, sewerage, telephone, gas and other services to nearby apartment blocks. Within 9 months of the start of the project, the diaphragm walls, caissons and columns were complete, and the ground floor work underway. Once again, extensive reinforcement was necessary for the heavily loaded slabs that span between columns and perimeter walls. With ground floor slab construction complete at one end of the site, excavators began removing soil down to first basement level. Soil conditions were extremely variable. Sand, silt, boulders, and relics of previous structures such as timber piles were often encountered. As the work progressed, excavators were lowered onto the first basement level. Typically, each level required moving 12,500 cubic meters of soil, this being hoisted to the surface by a pair of 15-ton gantry cranes. As each floor level was reached, the slab coupler reinforcement originally cast into the columns were exposed, each section of bar in the slab being connected by threaded coupler to the horizontal column reinforcement. Beam reinforcement cages were then assembled linking each column. Once this was done, the main floor reinforcement could be completed. The candy-striped concrete trucks became a familiar sight as they wound their way through the streets surrounding the construction site. 2,500 cubic meters of concrete was required for each basement level, and once again, extensive shift work in order to complete each floor in a cycle time of around 4 weeks. More often than not, pouring was done at night, when the ambient temperature had dropped from its typical 33 degrees Celsius daytime high. Night work was not without its problems, though. Plant noise had to be taken into account, and either work had to be limited or temporary sound baffles employed. The early stages of construction had showed a need to remove a large proportion of rock at lower levels in order to supplement the conventional top-down excavation. This is where the joint venture's mining expertise was called upon. The scheme required that a large diameter shaft be sunk, complete with mining headgear at the top. Near the bottom of the shaft, 2 levels of headings were excavated, interconnected by a series of ore passes. These headings served the dual purpose of access for geological investigation and, by means of winch-operated drag lines, the horizontal transportation of rock. From the initial development of small headings, these were enlarged into caverns by widening and deepening the upper levels until the excavation reached the lower level. This would enable approximately 9,000 cubic meters of solid rock to be removed prior to the excavation top-down reaching the cavern levels. This operation entailed leaving a 5-meter thick crown pillar of rock above the cavern. And to monitor rock movement in the roof, extensometers were installed. Within a year of commencing work, the excavation top-down reached rock level, and new tools became necessary. Drilling into Hong Kong's hard granite became an exasperating task, slowing excavation work by half. Blasting supervision was carried out by the Marple's mining specialists and MTR personnel. Nearly 10 tons of dynamite were needed to facilitate the excavation of each lower level, the average rock haulage being some 700 tons per day. Particular care is taken when blasting the rock surrounding each column, for although the rock has to be broken up, the column itself must not be damaged. The ore passes connecting with the lower caverns became particularly useful at this stage, the debris being taken down to the bottom of the shaft and then by hoist to the surface. The use of this and other typical mining techniques resulted in an additional 500 tons of granite being taken out every day. Then, 16 months from the start of the project, the bottom of the diaphragm wall was reached.
Rock excavation has now reached this profile.
Most of the diaphragm wall required underpin extensions to reach a founding level in rock some 20 meters below ground level. But before underpinning could be started, heavy steel propping was installed to strut the base of the wall, which remained in place until the underpins were complete, an upper platform slab cast. After 20 months from the start of the project, the last 3 basement levels were completed, having been blasted out in a continuous operation, leaving a huge cavern some 35 meters below ground level. This was a sight that gladdened the hearts of all those concerned. The most difficult part was over. Just one major blast remained. The breakthrough into the tunnels was achieved 30 days ahead of schedule. For the men who had worked so hard on the venture, there remains just about the only major conventional construction in the entire project, forming the lower 3 slab levels from the bottom up. Also a year of finishing work, a year of terrazzo tiling, painting and plastering, drainage and plumbing. But also a year to consider what 7 Down had become for many of the engineers. One of the most challenging projects in their careers. And for Marples International, a unique opportunity to contribute to the development and prosperity of one of the most exciting cities in the world.